Well, hello. How are you? How's it going? Thank you very much for watching this lecture video. I'm here with another lecture from organic chemistry. We're talking about alcohol and how to prepare different alcohols. One method, it can be nucleophilic substitution. We can depends the order of the carbon. We might get a primary, secondary, or tertiary alcohol. And we're going to start with here, the alkyl halide that we have is a primary alkyl halide. We're going to treat it with a strong nucleophile. How do I know it's a strong nucleophile? Because I have sodium with a positive charge. That means the OH, it will have a negative charge. So OH, it has a negative charge, and that's going to be my nucleophile. And nucleophile, because it has a negative charge here, it will be a strong nucleophile. The nucleophile is going to kick the chloride out of the system, and it will reach carbon from the back. This is the alpha carbon, and we get this product. And OH will show up wherever we had the halide. This is the alpha carbon, and now we got a primary alcohol. And the second product will be sodium chloride. And the second reaction is going through SN1. In SN1, we will have an intermediate, and because our nucleophile is a weak nucleophile, while the alkyl halide is a tertiary alkyl halide. That means it is going to have a plenty steric effect there. And because we have a weak nucleophile here, first step of the reaction is going to start with creating a carbocation. And so the chloride is going to take those 2 electrons and it will leave the system as Cl-1. Now, next step, our nucleophile, which is the solvent, it can reach the the carbocation from the top or the bottom. Again, our nucleophile is H2O. And this is going to be the product. Okay, so forgive me. And so I'm gonna get this one. If the addition happened from the top, then we get OH on the top of molecule, or we might get this one. In addition happened from the bottom of the molecule, and OH, it will show up there. In this case, they are identical because I don't have a stereo center. And but it's possible to get enantiomers, not in this case. Okay. Now, as you saw, like the first one, because it was the alkyl halide, the primary alkyl halide, I got primary alcohol. The second one is a tertiary alkyl halide. My alcohol is a tertiary alkyl halide. And well, how about this secondary? Forgive me. The last one was a tertiary alcohol. And how about the secondary alcohol? The secondary alcohol, we can get it through different methods. And so I'm going to show some methods that they are capable of actually creating different range of alcohols. And the first one is going to be the diluted acidic solution, the diluted aqueous acidic solution. And I'm going to call this one 1, and this is going to be 2. In both cases, the reaction will follow Markovnikov's rule. That means the OH will show up on a carbon with more substituent. And here we have a primary carbon. This one is a secondary carbon. So the OH should show up on the secondary carbon. And as you see, in first and the second one, we got secondary alcohol. The last method, when we are using boron compound, we get anti-Markov product. What does it mean? It means the OH, it will show up on a carbon with less substituent. And this one is a primary carbon, and the OH showed up there. So we got a primary alcohol. Okay. And so like this technique that I'm using here, okay, the 2 of them are giving me secondary alcohol, another one gave me primary alcohol. Let's go after them one by one. The first one, we have aqueous acidic solution. And if it's acidic, and we know acid is going to release H plus inside the solution and an ion. And I do have water. It says diluted. That means we have plenty water inside the solution. Water is going to be the nucleophile. Whenever we want it, it will behave as nucleophile. And I have an alkene that's one side of is a primary, another side is a tertiary. And when we treat it with acidic solution, the first step of the reaction is going to be this. Oh, the H plus is going to be added to this carbon to create a tertiary carbocation. Okay, a tertiary carbocation is more stable than secondary or primary. And the next step of the reaction, our nucleophile will get involved, and the nucleophile is H2O. So you can say this H attached to O attached to another hydrogen, highlight OH, and add OH to the carbocation. And when you add it to the carbocation, it depends from which side you're adding it. You will get a mixture of R and S as a product. So this is going to be the product. If the addition happened from the top, then we have OH on the top, or the second one, it will be this. Okay. And I'm going to add OH to the bottom of the molecule. And here we go. And I forgot that we have ethyl here. So let me add the ethyl, and that's not a methyl. Okay. Now, because I have 4 different substituents attached to this carbon, that carbon is going to be a stereocenter. And so I'm going to say the reaction will give me R and S product. And our alcohol is attached to a tertiary carbon, so it will be a tertiary alcohol. Okay. Another method is we have oxymercuration, demercuration method that it can take double bond and turn it to, and it will technically it will add H and OH to it. And let's go after the reagent first, and then I will go in detail of that mechanism. The first one that we have OAS, that's acetate. Anion acetate is CH3, attached to 2 oxygen. One of the oxygen, it has a negative charge, while the second one is neutral. Of course, we do have resonance between those two oxygen. Next one, we have sodium borohydride. We know sodium is a +1, so borohydride is going to be -1. And this is going to be a boron attached to 4 hydrogens. If you attach 4 hydrogen to it, you will find that the charge is going to be -1, and this is the proof for it. Boron is a group 3, but I see 4 electrons around it. So I'm going to say -4. That means it's -1. It has a formal charge equal to -1. And the -1, it will be canceled by positive charge of sodium. And so I have to say this. Hydrogen here, it will have -1, and it will behave as hydride. It's not hydrogen and cation. It's not H plus. It's H minus. It has an extra electron. That means it can behave as nucleophile. Okay, it can behave as a nucleophile and get rid of living group. And mercury with 2 acetate. Mercury is going to have 2 electrons or lone pair there, and that lone pair, it can behave as nucleophile. First step of the reaction is going to start this way. You will have mercury that's attached to 2 OAC, and the double bond. Okay, that double bond, it can actually move those 2 electrons. They can move to one side, and now that we have 2 electrons there, those 2 electrons, they will attack the mercury, And mercury, because it has two electrons here, those two electrons at the same time, they will attack the tertiary carbon. So we have a secondary and tertiary carbon. Now, let's add mercury from at the bottom of the molecule. If we add mercury from the bottom molecule, we'll have mercury here. Okay. While mercury is adding one of this OAC, it will take those two electrons and it will leave the system. So I'm going to get this. Okay. I will have mercury bridged bridge between those two carbon, and because I added mercury from the bottom of the molecule, and the methyl group that I had, it will go up. Okay, so now that methyl is up, well, that one is down. From day one, from was pointing down. Okay, now what else I have? I have another OAC attached to mercury, and of course I have one AOC that left the system, and that one it will be okay out of the system. So maybe I should write it here. Maybe I should write it there. Okay. And now mercury by itself, it has a positive charge. And because it has a positive charge, it's going to try to steal electron from carbon. This is a secondary carbon, while that one is tertiary carbon. And that means this bond is a weaker bond. Okay. This bond is going to be a weaker bond. If you have a nucleophile should attack the tertiary carbon. And what's the nucleophile? Our nucleophile is water. So this is the role of water. Water is going to attach carbon, and it's going to attach it from the opposite, okay, from the opposite direction. So addition is going to be anti, okay? Addition of the nucleophile, it will be anti. We have the mercury down here, so I'm going to draw the mercury down there attached to OAC, and OH it will show up on the top. Okay, I got the OH from water, and now if OH is up, that means the methyl, it will be down, CH3, and I'm talking about this, forgive me, this CH3. Okay, now CH3 went down. Okay, so you write this one down, and that one also down. Okay, next step, I'm gonna add the bore hydrate. One of this hydrogen will take the two electrons and it will attack this carbon. Okay, and because mercury is trying to steal the electrons, it's already creating a positive charge on carbon. So if we have a reducing agent there, or anything that it has enough negative charge to keep the mercury out of the system, it will do it. And so very soon I will have H. Okay, I will have H here. Okay, I added like in what else? I have OH there, and remember we had CH3 here. Okay, and okay, so the product is going to be something like this. We had methyl there. Okay, now OH is up, so I'm going to draw the OH pointing to us. This is going to be OH. Now, what will happen to the methyl? Methyl, it will be down here. This is going to be CH3. And of course, we had another CH3 there. Okay, the addition of OH, and it will be anti, and OH, it will show up on a carbon with more substituents. And here, remember, you do have two hydrogens. Okay, now what will happen if you use, methanol instead of water? If you use methanol instead of water, this piece, it will be added to the system. And in this case, you will have CH3O, and here you will have methyl. Okay, and of course, there I'm going to have two hydrogens. So no need really to write the hydrogens. Okay, And the bottom line is just simply add nucleophile to a carbon with more substituent, okay, to the tertiary one. And can I add it from the bottom of the molecule? Yes, it's possible. You can actually add this one from the bottom of the molecule. In that case, you will have OCH3 down there, and the methyl, it will be pointing to us. So that means we're gonna get a mixture of R and S. Okay. Yes, we get enantiomers. And we had, okay, we had the same thing here. And so you get enantiomers. So technically you get, this is a stereocenter, and I do have another stereocenter here also. And so, okay, I have 1, 2 stereocenters, and because I have 2 stereocenters, in this case, actually, I get diastereomers. I get diastereomers. Okay. And so how about this one? Yes, the configuration here, if the configuration right now is gonna be, let's check. And this is gonna be 1, 2, 3. Okay, 1, 2, 3. If I look at from that side of the molecule, and we have a hydrogen pointing down, so it's gonna be 1, 2, 3. This is gonna be a S configuration, so this one it will be R configuration, and but remember that you do have a stereocenter there. Okay, and those 2 stereocenters that I highlighted, I'm talking about this stereocenter and that stereocenter are enantiomer. Okay, enantiomer. But you do have 2 stereocenters, so it's better to call them diastereomers. Okay, and last thing that I want to cover, it's going to be the hydroboration oxidation. The mechanism is really a sophisticated mechanism. I can present it and go through it, but and still we don't know full detail of the mechanism. But this reaction, it will give you product that they follow. Technically, they go opposite of Markov-Nikov rules. We have a secondary, and here tertiary. Tertiary carbon, the addition will technically happen in a way to get at alcohol with less order, or alcohol will show up on a carbon that has less substituent. So alcohol, it will be here. I'm going to add alcohol to the top, and then what else? We will have also hydrogen. And hydrogen is going to be on the same side that we added OH there. What will happen to the methyl? Methyl has to go down. So I got methyl back, and we say the addition is going to be syn addition. That means both OH and H, they will be on the same side. Or you can add them at the back of the molecule. So you add OH here, and then hydrogen is going to be back of the molecule. That means the methyl will be facing to us. So we're going to put the methyl here. This is going to be CH3. Okay, and again, the addition, it will be syn addition. And OH and hydrogen, they were added to the bottom of the molecule, and because we added to the bottom of the molecule, the methyl that was inside the plane, now it will go up. Okay, and so I practice 3 methods for you to get different version of alcohols, and I hope this lecture is going to be useful to learn more details about alcohol or how to prepare them. Thank you very much.